So previously we made a planetary gearbox, and by itself it's a pretty cool little model and doubly amazing that I was able to pull it off without access to a CNC, an EDM or some type of universal milling machine. In fairness though, it did take about 3 to 4 hours just to cut the ring gear itself and countless attempts to try and perfect the cutter. And as far as these types of gearboxes go, they're actually pretty useful with a ton of upsides. For one, the power stays in the center axis, which is one of the big reasons why they're commonly found on cordless drills. They're also very compact for what they are, they're very efficient, 95+%, and they're incredibly strong, because the force is spread over multiple planet gears. And there's also a ton of different gear ratios which you can get depending on how you set it up. So if you use the standard setup, which uses one stationary, one input, and one output, there's going to be 9 different gear ratios, compared to 2 with a normal gear train. However, the sky is kind of the limit if you choose to have 2 inputs and 1 output, which is a very common setup to do. And by that I mean you use the ring gear and the sun gear as 2 different inputs, which will affect the planet carrier as the output. And depending on their speed, they will drastically change the speed of the output. Which I guess brings us to the title of the video. Kind of ambitious if you ask me, but let me explain. Now I don't, but if you happen to drive a car with an old school automatic transmission, so not a DSG or a CVT, but a proper automatic transmission, inside of it, they're really just banks of planetary gearboxes and a bunch of clutches. I mean, in fairness, in the real world, they are remarkable pieces of engineering, but at their very core, they're pretty simple and they're mostly all the same. With that said though, for the longest time, I could never really wrap my head around how these things actually worked. I mean, if you don't already know how they work exactly and you try to have it explained to you in some sort of classroom or using one of those animated videos, it can sort of melt your brain. I don't know, no hate, but I never found those videos or diagrams particularly useful or intuitive. So what I thought I'd do, now that I've cracked the planetary gearbox, is simply make a demo model of an automatic gearbox. And this has been a project that I've wanted to do for a very long time for quite a few different reasons. I mean, number one, just to really push myself and see if I can do it. It's going to be a stripped down model, but even so, there's going to be a lot of parts that go into this to make this work. 2, there's no better way of making sure that you understand something than going ahead and making it and then trying to explain it. 3, I think I can make it look like a nice art display piece and hopefully put it on a shelf somewhere as like a nice display model, which is actually one of the main reasons why I'm doing this. 4, I used to make these sort of models, not exactly like this, but I did make one of those inline 4 plastic engines that I saw on Top Gear a long time ago, and this sort of feels like a continuation of that, but a big step up. And 5, hopefully you learned something along the way, and I hope you enjoy this. Alright, so onto the design. I have a basic CAD model drawn up in SolidWorks. Now originally I was going to do a 4 or 5 speed gearbox, but I simply don't have the aluminium on hand to make this work. But really, if you understand how a 3 speed gearbox works, you'll get how a 4 or 5 or even a 6 speed gearbox works. It's essentially an extra bank or 2 of planetary gears behind the 2 that I have here. And in any event, 3 speed gearboxes were common-ish in the past, and this would have been the rough layout of a 3-speed plus reverse gearbox that you would have found in a ZF or Allison transmission. Of course there are going to be some differences just for sake of being able to make it, such as the pins that are going to be there instead of a shroud, and the clutches which will be slightly different, but on a technical level, at least as far as the gear ratios work and how this all goes together, this is very similar to how an automatic transmission would have been designed. So with the CAD model now done, let's get out and start making it. And the first thing we need is another planetary drive. Now yes, we did make one of these last week, so I'll try and breeze my way through making this one, although this one will be made slightly differently, and the differences are going to be important to making this work. So to start off, I have a piece of aluminium round bar, which is the perfect size for the main body / ring gear. And to save that centerpiece of material for later, I'll simply cut it out with a hole saw. Someone did ask why I'm using wood tools on aluminium, and the long short of it is, wood tools are cheap and they're still made from high carbon steel, so as long as you keep the speed down and the coolant up, they'll cut through these without any problem. Of course you can get these with carbide teeth, but they're about 10 or 15 times the price of what I picked this one up for, and if I only need to use it about 3 or 4 times, it makes a lot more sense to buy the wood tool. Now that hole is going to be an issue later on, but we'll get to it when we get to it. With a ring gear though, we'll then bore it to the correct size to have the gear teeth cut, and then I'll machine in a recess on the back to accept the carrier plate. With that now done, I'll get a new 100mm piece of aluminium chucked in and then cleaned up. I'll then start to machine down the outside to fit into the recess of the housing. I'll then drill and ream a hole for the centre shaft. And finally, I'll get it parted off, or at least as far as the parting blade will let me go, before cutting it off by hand. Man, that happens every single time, even when I'm being careful. And that is a pretty good fit. As you can see, this carrier plate doesn't have that extra bit at the back, which we made previously. And whilst I have the piece of round bar in the lathe, I'll part off another disc and this will form the back plate. We can then get them in the mill and use the hole pattern tool to drill some mounting holes in the back plate and the housing. Now one change that I will be doing is that I'll be adding 3 extra holes further in on the outwards facing side of the back plate. First drilling and then using an end mill to get a flat bottom. Now these holes will match up with the diameter of the other drive's planet gears, and it sort of needs to because that is one method that I'm going to use to connect the 2 gearboxes together. Essentially the planet carrier of the first gearbox is going to drive the ring gear of the second. If that doesn't make sense already, don't worry, it will make sense in the end. The important thing though is that the holes match up. I'll also get 3 holes drilled and tapped in the planet carrier. Like last time, this is just for demo purposes and for ease of making. With that now done, let's start to cut some gears. And to keep it all simple, I'm going to use the exact same gear ratios as I cut last week. So I'll need a 72 tooth ring, a 36 teeth sun, and 3 18 teeth planets. Now the planets are simple enough. I have some 25mm bar stock, which I'll take down to size and then get them cut in the mill using the dividing head. Now the gears that I'm making here were a bit of an experiment, which I touched on last week. I used the neck size cutter down to give these gears a bit of extra clearance, and the result was a bit more backlash, and it really wasn't all that necessary. Even so, they still turned out alright. The sun gear was a bit more involved to make. Now I don't have any 40mm round bar to make the gear, but what I do have is that piece which I cut out using the hole saw, except it has that 20mm hole all the way through it. And really that is double the size that I need. With that said though, I should be able to press fit a piece of aluminium into that center hole to make it work. And those are our internal gears now done. Finally, I'll rip the dividing head off the mill and get it mounted on the lathe so I can cut the teeth on the ring gear. All 72 of them. And each one takes about 2 to 3 minutes to do. Now thankfully, I didn't break anything this time, so that sped up the process quite a lot, but honestly, if I did this again, I could really do with some sort of shaper. Till then, I'll have to stick with the poor man's shaper. In the end though, the results are pretty much the same, yielding a very nicely cut ring gear. And after all that, this is where we end up. Pretty much exactly where we ended up last week. Times 2. Although in fairness, we have a few extra, differently placed holes. So next, let's start on what is essentially a clutch. One of 2 clutches which I need for the gearbox. Now this one will sit on the input shaft and engage the outside of the first planetary gear set. And because it is a clutch, it can be engaged and disengaged. Now like pretty much everything else, it'll start off as a piece of that 100mm aluminium billet. After cleaning it up, I'll then get a 20mm hole bored through it. And once we're at 20mm exactly, I'll then get it parted and sawn off. Now back at the mill, I'll drill and tap 3 holes for driving pins. Again, there are better ways of doing this, but for a model with very light loads, this will be more than fine. And finally, I'll get it in the press and get a 5mm keyway broached in the bore. I'll be using a key to drive the clutch, which will also allow me to move it along the input shaft to engage and disengage the clutch. And I think that turned out looking pretty good. I'll also get the backplate off the first planetary gear set in the mill, and then I'll drill 3 holes so the clutch pins can engage and then drive it. With that now done for the moment, I'll now start to make the input shaft. I'll turn down the end to 10mm. This will be our first stage for our first clutch, and it will connect the input shaft to the central shaft on the gearbox. I'll then make a 20mm section for the key clutch plate which we just made. I'll also be using this section for mounting one of the ball bearings. And with that now done, I'll then get it parted and then flipped in the chuck. I'll machine down a step down, which will be made to just over 20mm to provide an interference fit on a ball bearing. I'll then machine another step down, which will be used for mounting the handle. And that is the lathe work now done. Now over at the mill, I'll find the centre of the part and then start to machine in a 5mm keyway. Now to do this, I'll use a 4mm cutter and then slowly open it up until we get a nice tight fit on our key. I'm sure if I used a 5mm cutter, it would be slightly oversized and we wouldn't get that nice tight fit. And of course, stating the obvious, but what I'm using here is a 4-flute cutter and it keeps getting gummed up with aluminium. This is obviously a pretty good example of why you shouldn't use 4-flute cutters in aluminium, but the reality is I don't have any small 2-flute cutters on hand, but if I take it easy and I use a lot of coolant, the 4-flute should work. And that is going to be a perfect press fit. I'll then start to machine in a similar slot in that front shaft, although I probably won't key it. Instead, I'll probably use grub screws. Finally, I'll machine away 2 sides to create 2 flats for the rear step down for mounting the handle. Alright, and that's the input shaft now done for the moment. The next thing I'll do is tackle the centre shaft. Now, unlike the previous gearbox, and probably somewhat unintuitively, the centre shaft of an automatic gearbox drives not 1, but 2 sun gears. They're both connected and they're going to be spinning at the exact same RPM, which is really weird the first time you see it, but trust me, it works, and once you understand it, it will make a lot of sense. Now I do want the fit to be pretty good, but unlike last time, I'll probably be using grub screws to hold the gears in place, rather than a tight press fit. Okay, that's now stuck. I'll then get in the dividing head and cut out a slot at one end, and this will allow me to drive it from the input shaft. The next thing that I need are some new pins for the planet gears to ride on. For the planets in the front gearbox, I'll make up a set of pins similar to those that I made last week, however the ends are going to be made larger to stop the gears from falling out. The pins in the other gearbox though will be quite different. Like the others, they'll get a section for the threads and also a shaft for the planet gears to spin on. However, these will be cut much longer than the other ones. Now these need machining done on the other side, so what I'll do is I'll rip off the normal 3-jaw chuck and then replace it with the collet chuck. The rainout is going to be a lot better and the gripping area is spread out over a larger area so it won't mark up the aluminium. I'll then get them mounted and then turn down the end to fit in the holes which we drilled in the backplate. And once they're made, I'll use the vise to tighten them into the carrier plate so they won't come loose. These should be good enough, but if needs be, I can always use a little bit of Loctite. And after getting them all mounted, this is what the rear carrier plate will look like. And this is the front carrier plate. Obviously, minus the sun gear. Next we'll start to make the coupler / clutch sleeve for driving the center shaft from the input. I'll then get in the dividing head in the mill and then, or I guess maybe not. I always forget that the bore is something like 12mm. Now I could put it in the vise, but the DRO is already centered on the center line of the dividing head, so instead I'm going to take the lazier option. Now after drilling the holes, I'll then tap them for M5 and then screw in some grub screws. These will do the same job as keying them would have done. I'll then get it back in the lathe and then run the reamer through it just to clean up any burrs. And then I'll get it parted. Alright, that looks pretty good. What I need to do now is find a way of holding this all together. And whilst I did model up the gearbox in CAD, what I neglected to do was model up how I'd hold it all together. And how I'd display it. Sort of a figure it out when I get there type of design. And to be honest, I don't really have enough metal in the right shape to be used for the bearing supports and pillars. Thankfully what I have a lot of though is a ton of cast acrylic sheeting. It's a little bit big, but it is the right colour and should do for what I need. So whilst I have my materials sorted, my internal visualisation of how all of this will go together was a little bit flawed, as you'll see in a second. First things first though, let's cut out a block of acrylic using a handsaw. I'll then get in the mill and cleaned and squared up. Judging by the burning and tear out on that acrylic, that end mill is way too blunt for the acrylic. Thankfully though, the face mill is loaded up with brand new sharp inserts and it just tears through the acrylic, leaving a pretty good surface finish. So I'm pretty happy with the cutter, although it does tend to throw acrylic and acrylic dust pretty much everywhere. So when I was doing this, I did have to wear a respirator. And once it was all cleaned up, I'll then take 10mm off the front face to slim it down to the final width of the bearing that I'm going to be using. I'll then get it upright and then drill and tap 2 M5 holes for mounting it. Finally, I'll come in with a boring head to make the holes for the bearings. With those now done, I'll drill a hole through the sun gears and then get them tapped for M5. This will be for holding them to the main shaft. And with that all now done, these are now the parts ready to be assembled for a first test run. I'll start off by getting the two bearings pressed onto the input shaft. I'll then measure up a key and then get it cut. I'll then get the key pressed in and then the clutch mounted. Then we'll get the second clutch / coupler on. With the input side now assembled, I now start to assemble our main shaft. And it was at this exact point that I realised that I'd messed up. Obviously I've now mounted 3 pins, and with them in the way, I can't mount the bearings and its holder like I initially assumed. Honestly, not really sure what I was thinking, and I'm not exactly sure how I managed to screw that up, so I guess it's now back to the drawing board. Instead, what I might just do is have the ring gears resting on a few pieces of plastic with arcs cut out. I did model up several other solutions, but they either obscured the front gear, which I didn't really want to do, overcomplicated the design, used up too much metal which I didn't have, or just looked plain ugly. This won't be a perfect solution, but I do like the look of it. So what I'll do is I'll get a piece of plastic cut down, and then I'll come in with a hole saw to cut that arc. And this is roughly what it will look like. It's not perfect, but I do like the look of it. Another thing I also forgot to do was make the pins for the first clutch, so I'll also make those too. Finally, I need a big slab of material for the gearbox to sit on and be mounted to. I initially considered a hardwood, but considering that the black acrylic works so well for everything else, I see no reason not to just use it again. So what I'll do is I'll get another piece cut out. Well, I think that'll now be the bottom face. With it cut out, I'll then get it in the mill and then clean it up. And because I will be displaying it, I'll go ahead and chamfer the edges, and the face mill with these sharp inserts do a fantastic job at doing that. I'll then go in and drill and counterbore the screw holes for mounting the supports. And with that now done, this is what it looks like now roughly assembled. However, before I do the final assembly, I do think that all the aluminium pieces can be torn down and then sanded up just a little bit. It's been well over a month between making the first and the last pieces of aluminium, and aluminium has a habit of picking up small dents and light scratches. I mean, the clutch plate, for instance, has quite a few small scratches, so what I'll do is I'll turn down a 20mm arbor to be a good press fit, which I can use to tightly hold the clutch plate and then sand it. And I can do the exact same thing for the ring gears, although they are a bit more beaten up. With that now done, I'll then get the handle attached to the input shaft. All it really is a spare die-cast handle for a dividing head that I'll simply repurpose here. I do need to machine up a small handle to go into the end. And with all that now done, I'll now get the brown paper coating removed from the acrylic. Alright, ladies and gentlemen, may I present my automatic gearbox model. Honestly, genuinely, really proud of how it turned out. I know it probably doesn't look exactly like what you would find in a car, but this is pretty much the exact underpinnings of how a 3-speed automatic gearbox would work. The gear ratios may be slightly different, but in the end, you get 2 planetary gearbox and these sets of clutches. And once you get how this works, you'll quickly understand how a 4, 5 and a 6-speed works. And mechanically speaking, this thing works like an absolute charm. It was a bit sticky in the beginning, but a little bit of grease went a long way to making this work. Especially the clutch, which was pretty sticky. Now speaking of clutches, initially the plan was to have several clutches that would bite onto and hold the ring gears in place. But after making the base plate, I liked the design too much that I really didn't want to add anything on either side of the gearbox. After all, this is still intending to be a display model. But that really doesn't matter a whole lot because in the end, all you have to do is hold the planetary gearboxes to act as the clutch. And I'll show you all that and more in the next video. But seeing how this is already my longest video to date, you'll have to wait till next week to see that happen. There is a lot to be said on these gearboxes and how they run, and that really does deserve its own separate video. So we'll cover that next week. Outside of that though, I just hope you enjoyed this video. This has really been one of my favourite projects that I've ever done, and I'm just so happy with how it turned out. I just think it looks really beautiful, and I think this is going to be a great display piece. And with that, I hope you enjoyed watching this video, and I guess I'll see you next week. Take care.